Okay, this is the graph of f prime, and it gives us a couple data points that we need. So part A is asking to find local min. So first of all, I know local mins can only occur where the derivative is 0 or does not exist. And I see a derivative is 0 at x equals 1, x equals 4, and 6. I don't see any places where this value does not exist. Remember, this is your derivative. But local mean also means that I'm looking for a sign change from negative to positive. At 1, the derivative stays positive, so that can't be a min. At 4, it goes from positive to negative. That's a max. So 6 is your local min, and it only asks you for the x value. Don't give them the y. And your justification is because f prime is 0, and sign f prime changes from negative to positive. Okay, part B, determine the absolute minimum. So let's think about what we need to check for absolute min. Okay, again, the same possibility exists for these values, but I just said that 1, the sign doesn't change, so it can't be a min or a max. 4 was a max when I looked at the sign change, so it can't be an absolute minimum. So 6 is still a possibility. That local min could still be an absolute. So I'm still need to figure out if 6 is a possibility. The only other possibilities for an absolute are the endpoints, so I need to check 0 and 8. Okay? Now I need to take these and find f of 0, f of 6, and f of 8. So what we will need to do is we will need to integrate f prime somehow. But the only value that you know information about on the original is that f of 8 is equal to 4. So in order to find f of 6, f of 0, etc., you will need to use this condition. So I know I'm going to integrate f prime. Let's say I want to find f of 6. I'm going to use 6 as one of the bounds, and I will use 8 as the other bound because that is the only point you have information about. And I know if I integrate f prime from 6 to 8, fundamental theorem says I get f, plug in the upper bound, subtract off the lower bound. Now this piece right here we're going to do graphically. What is the integral of f prime from 6 to 8? Well, here's 6, here's 8. It's just the area underneath the curve, and they tell us that that value is 7. So this is 7. F of 8 we know is 4. I don't know f of 6. I can solve for that. I figure out that f of 6 is negative 3. Okay, now I also need to figure out f of 0. So I'm going to do the same thing. I'm going to use 0 as a bound. I'm going to use 8 because that's the piece that I know information about. If I integrate f prime, I get f of 8 minus f of 0. This piece, again, I'm going to do graphically. The integral of f prime from 0 to 8 is all of these pieces add together, but you're going to count this as 2, 6, count this as a negative 3 because it's below, and a positive 7. And if you do that correctly, this is 12. F of 8 I know is 4. So if I solve for f of 0, I end up that it's negative 8. The only other piece that I need to check is f of 8, which is 4, which is given. So if I compare these three numbers, this is the smallest number. So this is my minimum. This would be the work to justify your answer, showing that you compared all three. Okay, part C. I want f to be concave down, so I'm really looking for where the second derivative is negative, but the graph is only the graph of f prime, so which really is the same as f prime decreasing. So when I look at the graph, the only places where f prime, this graph is decreasing, is from 0 to 1 and 3 to 5. But I am also looking for where f is increasing. Well, f increasing would imply that f prime is positive, and that's only from 0 to 4 and 6 to 8. The only place where both of these statements are true is from 0 to 1 and 3 to 4. And your justification is f prime decreasing and f prime positive. Again, justify with what you are given. Okay, lastly, part D. They give you g is f of x quantity cubed. They want you to find the slope of the tangent line, which is the derivative. So the derivative of g, bring down the 3, reduce the power by 1, derivative the inside is f prime. At this point, plug in your values. 3 f of 3 squared times f prime of 3. They give you f of 3 is negative 5 halves. F prime of 3 we can pick out from the graph is 4. If I punch this out, I get 75.